Basically what we have here is a map of an archaeological site. What we're trying to do for this is basically find some test pits to sample, because on a dig they wouldn't want to just dig up the entire site without knowing that there's actually something in there for them to find. And for things like getting funding and so on, they'd want to have some evidence that there were some artifacts in there. They want to pick 12 test pits to actually dig in and then see how many artifacts they get out of there, and then that gives them an idea of how many might be in the rest of the site. So we're going to use those 4 different sampling methods to select 12 different test pits. Here's the idea. We're going to write 4 sampling plans, one for each different type of sampling, and each one has to give you a sample of size 12. So for each one you want to come up with a list of 12 test pits that you're going to dig in. So we're going to start out with the simple random sampling method. So for this first one, the simple random sampling method, this basically means you're not using any kind of organization. You're not dividing the population up into any kind of groups or anything. This is the equivalent of putting numbers in a hat and just picking out 12 of them. So that would be one method we could use. We could write down the numbers 1 through 100, or actually this is 120 that are in this population. We could write down the numbers 1 through 120, put them all in a basket, and pick out 12 of them at random. What we want to do is come up with a little bit easier way to do that. One thing that you can do with this is you can actually use StatCrunch to do just simple random sampling. In StatCrunch, to do a random number generator, which is all we're trying to do, you just need to open a blank data editor page. So it's the page that looks like a spreadsheet. To do that, just click up here where it says Open StatCrunch. And this is one of the applets. So if you click at the top where it says applets, and then scroll down to where it says random numbers, that's what we're using here, is a random number generator. So what this is going to do, we have to put in the lowest number that we want and the highest number that we want, and then tell it how many numbers we want it to pick out, and a few other specifics about it, and then it will go through and pick out the 12 numbers for us. So our smallest value, if you look at the map on the first page, the smallest value for one of those test pit numbers was 1. So we want to make that a 1, and the biggest number that we had was 120, down at the bottom right corner. Putting 120 in there. And then for my sample size, this is how many numbers I want it to pick out, so that would be the 12. Now this next part on here is really important, where it says number generation and it says allow repeats with replacement. In this case, we don't want to come up with the same test pit twice. That means we're doing this without replacement. So we don't want to get any repeats. So we're going to leave that box unchecked. So once you get those things filled in, then you can just click on Compute at the bottom. And you should come up with this little window that gives you your 12 numbers. And they should all be different. So yours should be a different list than mine. That's the nice thing about this, is that every time you do it, it picks out a completely random set of 12 numbers. Now the one other thing that we want to look at in this assignment is what kind of sample did that give you. So if you want to go back to the front page of this assignment, take that map and make some kind of mark on those 12 numbers that you came up with, so that you can see where those test pits are. So I'm going to do that for the numbers I came up with. So here's what mine looks like. If I was the archaeologist and looking at this, what I'd say is it looks like I have a lot that are kind of bunched together. I mean, there's a big space in here where I don't have any test pits. So I'm thinking maybe this isn't the best sample that I'd want to use in this situation. That one's kind of the easiest one to figure out, because all you're doing is throwing all the numbers in a box and then picking out a few of them, or using a random number generator. These other sampling methods, you have to think about it a little bit more. So the next one let's talk about is the systematic method. What this one means is that you look at your entire list of numbers, and you want to start with a specific one, and then you want to go every so many, and you want to make it go basically from the beginning of the list down to the end. What you have to do first is figure out how many you want to go between, so that you'll get the right number of test pits. We want a size of 12, so the easiest way to do this is take your total number that you have in your population, which is 120, and then figure out how many you want to be in your sample size. In this case, that's 12, and just divide those two. So 120 divided by 12 would be 10. That's going to tell us the N. So, and when we do this, we say we're going to pick every nth test pit. So this would mean we'd go every 10th one. That way we can go from the beginning of the list to the end and get exactly 12 test pits. We're not stopping too soon, or we're not starting too late, and we'll have it nicely spread out. Now the thing is, all of these sampling methods have to have something in them that's random. So in this one, if you just start with number 1 and then go every 10th one, that's not random because you chose the number 1. That means numbers 2 through 9 have no chance of being chosen. You still want to make it so that it's random, so that every test pit in here has a chance of getting chosen. For your starting point, that's the number you have to choose at random. So what we want to do is look at the numbers 1 through 10, choose one of those at random as our starting point. So you could put 10 numbers into a hat and draw out one. You could use that random number generator on StatCrunch, just something that makes that a random selection. And anytime if you're doing anything with choosing the number, it's not random. Even though you might think it is, that, you know, I say, what's a number between 1 and 10, and you come up with something. Almost everybody has some kind of bias. There are certain numbers that maybe they like better than others. If you choose it, it's not going to be at random because you're going to have some kind of bias. So I'm just going to go back here. I want a sample size of 1 because I just want the 1 number, and it picked the number 9. So you can do that on your own and come up with your starting point. So mine was 9, and so down here I want to fill in what's n going to be. So my n was how far I'm going in between. So my n for this would be 10. And then how I randomly select the first one, I use the random number generator in StatCrunch. So I'm just going to write that in here. And then I want to list the 12 numbers that would give me. So I'm going to start with number 9, and then I'm just going to add 10 to each one. So it'd be 9, 19, 29, and so on up to, it's going to end up at the end at 119. So I would list all those numbers in between. And you might want to go back when you're done and count up and make sure you actually got 12 of them. So this is a really good method a lot of times. The trick to it is that you do have to choose that one randomly so that you get the randomness in there somewhere. These last two, the reason I put these two at the end is because it's really easy to get mixed up between the stratified sampling and the cluster sampling. Because both of them, you split the population up into groups, but then what you do with the groups is different for each one. So for the stratified, you split the population up into groups, and then you take a certain number of individuals from each group. So you're taking things out of each group. For the cluster sampling, you split the population up into groups, and then you choose entire groups. So for example, if we had 20 groups and we decided to choose 2 of them, then we take everybody from that group. So in this situation, to use either of these two, one of the things we have to figure out is how we're going to split the test pits up into groups. For the stratified sampling, we have to figure out how we're going to do that, and then how we're going to randomly select the individuals from that group. This is the part of this one that's random, is that when we have the groups, we still have to randomly select individuals from the group. So that can be something like simple random sampling. Kind of think about this, talk to each other, and figure out some way that you could split this up into groups and how many you take from each group in order to get a sample size of 12. You want to end up with a list of 12 numbers. So, and there's more than one right answer here. So just think about that. Use your map. Think about what would be easy as far as splitting it up into groups. And then depending on how many groups you split it up into, think about how many you have to take from each one. So what did everybody come up with as far as splitting it up into groups? into columns. So you got 12 columns, right? And then you're choosing one from each column. So I'm going to write down the ideas here. So this is for the ideas for the stratified. So one way to do it is just use the columns. So there are 12 columns, and you can just use each one of those columns as a group. It depends how many groups you divide it up to. That tells you how many you're going to select from each group. 3 columns. And then you're picking 4 from each one. Okay. Okay. We're going to come back and talk about how to do that choice of the ones from each group. Does anybody else have something different? 2 groups of 5 columns. Columns are going down, rows are going sideways. 2 groups of 5 rows. Okay, my question for that is, how are you going to get 12? 2 groups, so that is 1 through 60 and 61 through 120. And then you're picking 6 from each. Okay. 1 through 20, 21 through 40, etc. So for that, you'd want to pick 2 from each group. Now the challenge for some of these is how to make those random selections from each group. For some of you, I was talking about if you are just doing this by 12 columns, so you've got each column as a group and you're only trying to pick out 1 out of each, then one way you can think about it, if you want to use like a random number generator, you can just think about each row being numbered. So this is row 1, 2, 3, 4. And then for each column, so for each group, if you're trying to pick out 1, you do a random number between 1 and 10, and that would tell you where in that column your individual is. So for example, if you did a random number generator and it came up with 4 for your first one, that would give you number 37. You'd have to do that each time for each of the 12 columns to make that work. You can't use the same number in each one, or then it's not random. So same thing if you're doing 3 columns. So if you're doing 3 columns at a time, you could number these from 1 to 30 and then pick out 4 of those, but you'd have to figure out how you had these ones numbered. So that way it might be a little bit more complicated. You could just break it up into 4 groups by going 1 through 30. So that would be this right here, and then go 31 through 60. So you'd still have 4 groups, but that would make the random number selection a little bit easier. So once you get that done, write down your 12 numbers and then go back to your map again and kind of mark where those came out. So doing that, what does your map look like? You think that's giving you a good cross-section of the test pits? Okay, so yours are pretty well spread out. Okay, better than the first one? How about for the rest of you, if you're done with that? How did yours come out on the map? Better than the first one? Okay. The problem with this is that if we make it random in any way, then it's not going to be perfect. I mean, if we want it to be perfect, then we would, just look at it and pick out specific places. But if we really actually want to make it a random sample, then it's not going to be exactly symmetric, or it's not going to be exactly spread out.
So are we going for perfect, or are we going for random?
We're going for random.
Okay.
We're not going for perfect because we're talking about random sampling. So let's go to the last one, and that's the cluster sampling. In this one, instead of picking a certain number from each group, we're going to randomly select some of the groups. And again, we want to make it so we end up with a total of 12 test pits. Again, think about how you want to split it up into groups, and then how many groups you're going to have to select to get the 12. So for example, you could split it up into 10 groups and then just pick one of the groups, because then that would have 12 in it. That would be a super simple way to do it. So just think about how you want to split it up and then how many groups you have to select. But you have to be able to take a whole group and get 12. You have to select, if you select something, you're selecting the entire group.
Can you test just one group?
You can. Yeah, so that's what I was saying. If you have it split up into 10 groups, each group would have 12 in it, so you could just randomly select one of those groups. But if you had to split up into bigger numbers, like if you had to split into groups of 20, that won't work, because if you select one group, you get 20 instead of 12. So you have to split it up a little bit more than most of you did for the biggest your groups can be is with 12 each. So you can either have 10 groups of 12 or more groups with less people. Did I lose you? Okay. That's why we're doing this. Okay, so this is for the cluster sampling. In this one, we're gonna select entire groups instead of just picking a few out of each group. So we wanna have enough groups so that each group has 12 or less. So for instance, we could do it so that each group has 12. So possibilities are each group has 12. In that case, we just pick one group and take all the test pits from that group. Or we could do it so each group has 6 in it. So this one, we choose one group. If we make it so that each group has 6 in it, then we choose 2 groups. That would give us 2 groups of 6, which would add up to 12 altogether. Or we could do it so each group has 4. And then to get 12, we'd have to choose 3 groups.
Would you like an example on here?
I'm going to, yeah. I'm seeing the look on your face. Okay, so let's try. Try what each group has 6. For each group to have 6 in it, if we take 120 and divide it by 6, that's going to tell us how many groups to have. So 120 divided by 6 is going to give us 20. So that means we want to have 20 groups. So basically for that, probably the easiest way would just be to go number from 1 to 6 and then from 7 to 12. So we could do it that way, and that would end up splitting this in half, and then we'd have it split by the rows. So if we did it that way, this is one way we could get those 20 groups. Okay, so we've got our 20 groups. So here's one group, here's another group, here's another group, here's another group. So that would be our 20 groups. So that would be going 1 through 6, 7 through 12, and so on. So we've got 20 groups. Each one has 6 in it. We want to end up with a total of 12 pits. So we're going to randomly select 2 of these 20 groups, and then we'll take every pit from that group. We could number these, say 1 through 20. So this could be number 1 group through number 10. And this could be number 11 through number 20. And then I'm just going to pick 2 of those at random. So I'm going to go back to here. I'm going to go 1 through 20, and I'm going to pick out 2. Okay, so that's giving me 18 and 2. So let's see, here's my group number 18 right here. So that would be this one. So there's 6 test pits, and then group number 2 would be right here. So this would give me another 6. So in this method, we're taking the entire group, but you have to randomly select the groups. So then my list of test pits, I'd have 13, 14, 15, 16, 17, and 18, and I'd have these 6 down here. Does that kind of make sense?
I think we might have done it wrong.
Not necessarily. For this method, you have to choose the groups, and then you take everybody that was in that group.
Yeah, we only did 3 groups.
Okay, yeah, you can't do it that way, because that gives you 3 groups of 40. So then if you even select one group, you're going to have 40 test pits. Yeah. So this one, that's what I meant. You have to make the group small enough so that there are 12 or less in each group. So these are some things that would work. So either each group has 12 or each group has 6 or each group has 4. You could also do each group has 3 or each group has 2. It's kind of like, okay, if you think of it, if we were trying to choose students to do a survey or something with the cluster sampling, one way we could do it is we could have a list of all the classes, and we could decide, say, how many classes we wanted to select. If we selected this class, then everybody in here would do the survey. So this would be one of our clusters. So if this class got selected, then everybody in here would be part of the sample. If we selected a different class, then everybody in that class. Instead of taking a certain number from each class, we would take entire classes instead. You want to pick a number here so that it'll multiply is something that you can multiply to 12. So it either has to have 12 or 6, because then 6 times 2 is 12, or 4 because 4 times 3 is 12. You want to make it something that you can multiply by to get 12.